Okay, we are back with the actual periodic table. So I'm going to share this link with you. It's called ptable.com. Uh, you are going to be using this in chemistry when you get to high school for sure. It's a very comprehensive and interactive periodic table. I just want to show you a couple things. So you just saw in our last video that each one of these boxes has information in it that tells you a lot about it. So the first thing that each one of these boxes, let's start over here with hydrogen, and it's going to highlight it right here. You can see the atomic number is at the top. That's how many protons there are. The symbol, the name, and then this 1.008 at the bottom is the atomic mass. Okay, so that is connecting those little boxes that we have just looked at. So today we're going to be talking about groups and periods. First things first, when we read the periodic table, we always read just like a book from left to right. If you notice, the atomic number goes up by one as you go from left to right. So I have hydrogen has one proton in the nucleus, so it has the atomic number 1. Helium has 2, then lithium has 3, beryllium has 4, 5, 6, 7, 8, 9, 10, and so on. So you always read that table from left to right, okay? The next thing that I want to talk to you about is when we're reading this table, you have columns which are vertical and you have rows which are horizontal, okay? Those vertical columns are called groups. They're also known as families. And the cool thing about the way that the periodic table is set out is that each column or family has very similar chemical characteristics, same properties, similar properties to the ones in that same family. And let's talk about why that is here. Okay, so getting started specifically with the periodic table. If you have the periodic table that I gave you before you left, awesome. If you have colored pencils, feel free to do this coloring activity. We were going to do it in class. Obviously, we're not in class right now. So if you want to, go for it. If you don't want to color it, that's up to you. I just want you to have a basic understanding of how to read the periodic table. Okay, so first let's start here. Elements, families, or groups. Those are those vertical up and down columns, right? So elements are going to be organized into families or groups based on the number of valence electrons. And if you remember, that is how many electrons are on that outside shell. So if I'm drawing an atomic model, this is going to be lithium, right? I know it's lithium because it has 3 electrons, but you can see on the valence electron, the very outside, there we go, the very, very outside electron, that's a valence electron. So since this only has 1 valence electron, it's going to go in group 1. Any element that has only 1 valence electron is going to go in that same group, okay? That also means the reactivity is going to be very similar. Man, I wish we were in class right now so we could talk about this all day long because chemistry is fun. All right, so the reason, let's back up a little bit. The reason why 2 atoms come together and bond and do a chemical reaction is because really all an atom wants in life is to have a full shell. Lithium, super not happy because in order to have a full outside shell, it needs like 8 or 18, depending on how many shells there are here. But you can see lithium only has 1. It wants at least 7 more to be complete, right? To be whole. So everything in family 1 is going to be highly reactive because it needs more electrons. So it's going to do that by bonding with other elements on the table to share electrons, steal electrons, sometimes even give electrons away, so that they can have that that shell balanced. Okay, so back to this periodic table. Everything in each of these columns, right, the families or groups, they're going to have the same number of valence electrons, and they're also going to have similar properties. Okay, says here on the bottom you need pencils. You don't need pencils if you don't feel like doing this. All right, so let's go on here. Again, these directions at the top, this is what you would be doing if we were in class today. But since we are not, that is okay. Okay, so we're going to go through this quickly. Each column or family has a name. You can see in column 1, this is going to be our alkali metals. This is the most reactive metal family, okay? Because again, it only has one valence electron, so it's super ready to pop off. It wants to bond really fast with something, or give it away, or share, or even steal an electron from something else. So anything in this family, really, if we look along the top, here's a secret rule. The family number is going to tell you how many valence electrons there are, except for with our transition metals. That rule will not apply. So family 1, 1 valence electron. Family 2, 2. We're going to skip over here to 13. There are not 13, okay? There are not, I repeat, there are not 13 valence electrons in group 13. There's only 3, okay? We're just going to forget that one is there, right there, okay? So family 1, 1 electron. Family 2, 2 valence electrons. Family 13, 3. Family 14, 4. Family 15, 5. Family 16, 6. Family 17, 7. And family 18 has 8. Okay, and we're going to get to this one here in a second because these are also some pretty special elements in that family. All right, so back to this. Alkali metals, super, super reactive because they need to have a complete shell. They want it and they don't have it. So family 1, because we want a complete shell, they're going to bond really well with pretty much almost anything from family 17. Most notably is table salt, right? So if I look at table salt, the ingredients for table salt, NaCl, or sodium chloride. This is going to be a super famous compound for you to know. Okay, if I'm looking at sodium right here, sodium's in family 1. Okay, it has that 1 valence electron. Okay, it needs 7 more. If I look at chlorine all the way over here in family 7, it means it has 7. 7 plus 1, kids, that's 8. If I get a chlorine atom, and I bond it with a sodium atom, I get table salt. That's what I get. And what's really cool about that is separately, these things are extremely dangerous. Chlorine is a noxious gas that could kill you. You go swimming in the swimming pool and it smells like there's too much chlorine and it burns your throat and your eyes get red and stuff. That's diluted. That's really watered down. That's not pure chlorine. Chlorine is a super noxious gas. They use it in warfare sometimes when it's just on its own. It's a horrible, horrible gas. Sodium, it's an explosive metal. Gets wet, blows up. Highly unstable. But because this has 1 valence electron and chlorine has 7, you get them together and it's harmony. You get table salt. You can put it on your food. It's delicious. Don't use too much. It'll give you hypertension. Okay, anyways, back to our thing here. Okay, column 2. Again, you do not need to color this if you choose not to. These are our alkaline earth metals. They have 2 valence electrons, and these are also really reactive. These are very reactive metals, not as reactive as alkali metals, but still pretty reactive. Transition metals, groups 3 through 12, they're cool. They're metals. A lot of our common metals that we have here: gold, okay, silver, tin, all right, iron, all those things. Sorry, I didn't take my allergy medicine this morning. My allergies are killing me. All right, so transition metals, they're cool. All right, the boron family, in group 13, which means it has, review, three valence electrons. Then we have our carbon family, 4 valence electrons, 5 valence electrons for the nitrogen family. Oxygen family, also known as the chalcogens, has 6 valence electrons. They are pretty reactive because they just need 2 more. They just want 2 more. So doing the math, kids, the oxygen family is going to go pretty well with everything in the alkali earth family because of that balance that we talked about. And then here we go, the halogens. The halogens are extremely reactive gas, okay? So fluorine, chlorine, here's chlorine. Look at that. Most reactive non-metal, best friends with the most reactive metal. Look at that. Look at that, okay? And then last but not least is the noble gases. Now, the noble gases, when we hear the word noble, you think of royalty and all that stuff, hoity-toity, better than everybody else. That's because they are. They are. And here's the reason why. Because the noble gases already have a complete shell. Everything in there. So it's kind of unlikely that they bond with anything other than something from their own family or themselves because they already have a complete shell. They don't need to bond with anybody. They're just like that. You don't have to worry about them. They got it together. Okay. So we're going to talk about periods in a second. Okay. So groups and families, the number goes with how many valence electrons there are. Now let's talk about periods, okay? Periods are the rows, okay? And the rows are going to tell you how many energy shells they are, right? So how physically big? Is it just going to be 1 ring? Is it going to be 2 rings, 3 rings, all the way up to 7 rings, right? So if I'm looking at my horizontal rows from the top to the bottom, this top period right here, this top period, only going to have 1 shell. What period 1? 1 shell. Period 2, 2 shells. Period 3, 3 shells. Period 4, 4 shells. Period 5, 5 shells. Period 6, period 7, right? So the further down on the table you go, the bigger the atomic structure is going to be, okay? Now looking here, if you have your periodic table, with your blue book, you can see they have them already numbered down the side here, right? That tells you how many shells, how big it's going to be. So when I drew lithium for you, here's lithium, I can easily find this on the table just by knowing a couple different things, right? One, it has 1 valence electron, so it has to be in family 1. And the next thing, how many rings does this little guy have? Oh, look at that, 2. So if it has 1 valence electron and it has 2 shells, oh, is that it? Could I be pointing to look at that? I was pointing at lithium and didn't even have to look, right? Periodic table looks confusing at first, but once you know how to read it and find things, it's really not that bad. Okay, so 7 periods, 7 rings. Okay, read the table left to right by atomic number. Groups and families, those are our vertical columns. Goes by valence electron. Okay, all right, let's see what else we got for you. Oh, I forgot to take out that little thing in there in the bottom. That's okay. How many valence electrons does each one have in the column? We already talked about that. Family 1, it's going to have 1. Family 2, it's going to have 2, and so on, okay? That rule does not apply to transition metals. So when you get over here to the boron family, you pick it back up with 3, okay? All right, so there we go. It's doing it for us. Oh, look at that, look at that, look at that. There we go. There is our valence electrons. And that's it for that. Let me make sure I covered everything. Oh, because of our groups and families, I'm just going to come back to this one, right? Because in the groups, in our vertical columns here, because those have the same number of valence electrons. Okay, this is going to go back to reactivity, and it's also going to go back to similar chemical properties. You're going to hear that, okay? So anything, so if I'm looking here in family 1, because these only have one valence electron, they're all going to react in a similar manner, okay? They're not going to all react the same, but they're going to react in a similar manner. They're going to have chemical properties that are in common, right? So if I'm looking at group 13, right, boron, aluminum, gallium, those are going to have similar chemical properties. Their chemical properties are not going to be similar to family 18. No, they will not be, because the reactivity is different, because the valence number is different number of valence electrons. Okay, I hope I covered everything for you in that super fast video. Let's see, similar properties, periods, little valence shell, most reactive, and why. We did that. The reason why they're most reactive is because of how many valence electrons they have. They want to have a full shell. The further away they are from having a full shell, the more reactive they are. That's why this noble family here, those noble gases, they don't need anybody because they already have everything they need. Okay? All right, so I'm going to stop this here. Hopefully it wasn't too long. Go ahead and take the learn check that says groups and periods, and I'll see you in a couple minutes. And the last thing we're going to talk about today is metals, nonmetals, and metalloids.